Newton's second law of motion. Second law of motion. The first law of motion indicates that when an unbalanced external force acts on an object, its velocity changes, that is, the object gets an acceleration. That is, when an external force is acted on an object, its velocity changes. When the velocity changes, it gets an acceleration. We would now like to study how the acceleration of an object depends on the force applied to it and how we measure a force. Let us recount some observations from our everyday life. During the game of table tennis, if the ball hits a player, it does not hurt him. On the other hand, when a fast moving cricket ball hits a spectator, it may hurt him. We know that a cricket ball is heavier than a tennis ball. The mass of the cricket ball is greater than the mass of tennis ball. So a fast moving cricket ball may hurt the spectator. A truck at rest does not require any attention when parked along a roadside, but a moving truck, even at speeds as low as 5 meters per second, may kill a person standing in its path. If we consider a bicycle instead of a truck, then what will happen? It may cause any injury to a person standing on its way. The force exerted by the truck is much greater than the bicycle traveling with the same speed. The mass of the truck is greater than the mass of the bicycle. So a moving truck even at a low speed can kill a person standing on its way. A small mass such as a bullet may kill a person when fired from a gun. When a bullet is shot from a gun, it will move with a high velocity. So the bullet shot from a gun make more impact that even kill a person. These observations suggest that the impact produced by the objects depends upon their mass and velocity. Similarly, if an object is to be accelerated, we know that a greater force is required to give a greater velocity. In other words, there appears to exist some quantity of importance that combines the object's mass and its velocity. One such property called momentum was introduced by Newton. The momentum p of an object is defined as the product of its mass small m and velocity small v, that is p equal to m into v. Momentum has both direction and magnitude. It is a vector quantity. Its direction is same as that of velocity small v. The SI unit of momentum is kilogram meter per second. Here the SI unit of mass is kilogram and the SI unit of velocity is meter per second. So the SI unit of momentum is kilogram meter per second. Since the application of an unbalanced force brings a change in the velocity of the object, it is therefore clear that a force also produces a change of momentum. Let us consider a situation in which a car with a dead battery is to be pushed along a straight road to give it a speed of 1 meter per second, which is sufficient to start its engine. If one or two persons give a sudden push or unbalanced force to it, it hardly starts. But a continuous push over some time results in a gradual acceleration of the car to this speed. That process we called starting a car. Starting a car means change the momentum from 0 to a certain value. It means that the change of momentum of the car is not only determined by the magnitude of the force but also by the time during which the force is exerted. It may then also be concluded that the force necessary to change the momentum of an object depends on the time rate at which the momentum is changed. Here, the time period in which the force that is, the unbalanced force applied is very important. We can say that the time period in which the momentum of the body is changed is depend upon the force applied to change the momentum of an object. So these are the basics of the Newton's second law of motion. The Newton's second law states that the rate of change of momentum of an object is directly proportional to the applied unbalanced force in the direction of force. Mathematical formulation of second law of motion. Suppose an object of mass m is moving along a straight line with an initial velocity u. It is uniformly accelerated to velocity v in time t by the application of a constant force F throughout the time t. The initial and final momentum of the object will be P1 equal to mu and P2 equal to mv respectively. The change in momentum is proportional to P2 minus P1. P2 is equal to mv and P1 equal to mu. Then it is equal to mv minus mu. That is m into v minus u. M is taken out from the equation, then we get m into v minus u. The rate of change of momentum means the time taken to change the momentum of the body, which is equal to m into v minus u by t. T is the time taken to change initial velocity to final velocity. From the Newton's second law, the applied force is proportional to the rate of change of momentum. Then F is proportional to m into v minus u by t. Now suppose we want to take out proportionality factor from a particular equation. We need to multiply with a constant to any of the sides of the equation. Here k is the proportionality constant that we use to take out this proportionality factor. Then force F equal to k into m into v minus u by t. Here v minus u by t equal to acceleration. Then F equal to k into ma. Here a is the acceleration, which is the rate of change of velocity. The quantity k is a constant of proportionality. The SI unit of mass and acceleration are kg and meter per second square respectively. The unit of force is so chosen that the value of the constant k becomes 1. For this, 1 unit of force is defined as the amount that produces an acceleration of 1 meter per second square in an object of 1 kg mass. That is, 1 unit of force equal to k into 1 kg into 1 meter per second square. Thus, the value of k becomes 1. Then F equal to ma. The unit of force is kilogram meter per second square or Newton, which has the symbol N. The second law of motion gives us a method to measure the force acting on an object as a product of its mass and acceleration. The second law of motion is often seen in action in our everyday life. Have you noticed that while catching a fast moving cricket ball, a fielder in the ground gradually pulls his hands backward with the moving ball? In doing so, the fielder increases the time during which the high velocity of the moving ball decreases to zero. Thus, the acceleration of the ball is decreased and therefore the impact of catching the fast moving ball is also reduced. If the ball is stopped suddenly, then its high velocity decreases to zero in a very short interval of time. Thus, the rate of change of momentum of the ball will be large. Therefore, a large force would have to be applied for holding the catch that may hurt the palm of the fielder. In a high jump athletic event, the athletes are made to fall either on a cushioned bed or on a sand bed. This is to increase the time of the athletics ball to stop after making the jump. This decreases the rate of change of momentum and hence the force. Try to ponder how a karate player breaks a slab of ice with a single blow. Because a karate player strikes the pile of tiles or slab of ice with his hand very fast, so large momentum of his hand is reduced to zero in a short interval of time, which exerts a very large force on the pile of tiles or slab of ice to break them. The first law of motion can be mathematically stated from the mathematical expression for the second law of motion. F equal to ma or F equal to m into v minus u by t or Ft equal to mv minus mu. That is when f equal to 0, v equal to u for whatever time t is taken. This means that the object will continue moving with the uniform velocity u throughout the time t. If u is 0, then v will also be 0. That is, the object will remain at rest. Because the first law also included in the second law. First law gives the quality of force applied and the second law gives the quantity of force in the unit Newton F equal to ma. If F equal to 0, then A equal to 0. A body which is at rest will be at rest, and if force applied, there will be a change in acceleration and body moves. Thus, the first law of motion can be mathematically stated from the mathematical expression for the second law of motion. Summary: the rate of change of momentum is proportional to the applied force. Force equal to mv minus mu, which is the change in momentum divided by t, which represents time. Here, force is inversely proportional to the time. Momentum represented by t is given by mass into velocity. The unit of momentum is kg meter per second. Force equal to mass into acceleration. Unit of force equal to Newton. It is represented by capital N. 1 Newton equal to 1 kg into 1 meter per second square. Newton's second law is helpful to calculate the Newton's first law. This is all in this topic.